Then we are ready for the next talk. Welcome, Juhis, all the way from Finland. Thanks for joining us, not for your first ever Django Day talk, but actually for the second one. One virtual, one physical now. I think we should give Juhis a warm welcome.
Hi, everybody. It's been such a wonderful day. Really great talks. A lot of nice discussions with amazing people. 2 years ago, this was my audience when I did the talk at Django Day Copenhagen. And not a lot has changed because I think my biggest fans are still in the front row, just like they were. And it's been 2 years in the making. I really wanted to come here in 2020 to do my talk about documentation. But we all know what happened. It took a couple of years for me to come here. But I was really drawn into by the promise of the cake. Us being in Denmark being famous for the pastry, I didn't want to miss that for anything. So this year, when the world opened up, I really wanted to make the trip and this time talk about debugging. And to get started, I want to know a little bit about you. Do we have a...
Yeah, it's just not updating on the internet. Can you please go here and then share, stop sharing, and then start sharing again? Yes, please. Thank you. How does that look, Mass?
Try to do the next slide. Yeah, that was.
All right, that. Then we go there. Does it update now? Good. So like I said, I want to know a little bit about you. So if you have ever written a bug, please raise your hand, even if it didn't make it into production. Yes. To the internet viewers, everybody raised their hand. And I think that's expected. As software developers, I think it's impossible not to write bugs. Software is complex. Translating abstract kind of business ideas into technical details is not one-to-one mapping. It's a challenging venture. And if you've ever written a bug, or you've worked with a code base with other people's bugs, you've probably had to do a little bit of debugging at some point. My name is Juhis, and during the day, I work as a developer advocate at a company called Futurist. And kind of an accidental part of my job is that I end up helping a lot of developers debug stuff because I tend to have a lot of extra time. So people come to me to kind of use me as a sounding board, figure out what kind of problems they have. I've also been teaching programming and coaching juniors for the past decade. And in both of these kind of circumstances, I've noticed a certain lack of skill in debugging. And that's why I wanted to do this talk and hopefully give you some tools and ideas for how to become good at it. I also happen to be a big board game enthusiast, and I'm going to be in Copenhagen for the weekend. So if somebody wants to get together tomorrow or Sunday, grab some beers, play some board games, I brought a bunch of my favorites with me. Hit me up after the conference. So debugging is something that most people don't really like. For me, it's one of my favorite parts of software development. But it is usually a negative thing because it is associated with stress. Debugging only happens when something goes wrong. And when something goes wrong, things get stressful. And stress is almost never a good thing. And there are a couple of reasons for that. One is the deadlines. Like was mentioned in the previous talk, we live in a real world. We have deadlines. Things need to happen. And if you get a bug on Friday afternoon, maybe sitting on the back row of a conference, and you get a call, things are not working, it is stressful. You end up trying to figure something out. expectations. This industry is kind of plagued with imposter syndrome. Am I good enough? Did I write this bug because I'm not good enough? Or am I expected to solve this problem much quicker than I can? And that can be stressful. We also have external expectations from our team, our manager, the client, the end user. Everybody wants things to run smoothly, to work as intended, and that can cause a lot of stress to us. And when we deal with debugging, it is the unknown that is stressful. I don't know why my code doesn't work, because if I knew, I would have already fixed it. So when you enter debugging, you don't know what you're doing, and you have all these other things that expect you to make things happen. So I'm going to talk about three main things today. I'll start with the fundamentals that apply to any kind of debugging, regardless of the programming language, regardless of the software you're building. Then we're going to take a look at some tools and techniques specific to Python and Django. And in the end, I'm going to talk about a couple of non-technical methods. Because for me, debugging is not a technical problem per se. I don't think it can be solved even with the best tools. It's more of a mindset and an approach that makes you effective in debugging. Couple of things I'm not going to talk about today that are kind of related are things like testing, monitoring, logging. I think they are essential part of the entire process. But I think they happen around the discovery process that is debugging. So let's start with the fundamentals. The first and the most important thing when you encounter a bug is to stop. We have this tendency that when we get something like a bug, we want to fix it as quick as possible, especially if it's Friday afternoon. We want to rush into it because we want this nasty negative thing out from our lives. But I think we all know deep down that rushing into things just makes more problems. You might make a hack that fixes that bug, but it might introduce a couple of others down the line. Or at least create tech debt in form of bad code. So even when things are stressful, you need to stop, take a breath, in and out, and assess the situation. It's not the end of the world. It's not the most crucial moment. And kind of collect yourself, be analytical, be calm, and approach things as you would any other part of software development. And the next thing is to start from the end. And this is the thing that I see most often when I help people develop debug. They struggle with this idea. Because as software developers, the code editor is our world. That's where we live in. So it's natural for us to reach into that. Oh, I see a bug in the front end. Let me open the code editor and look at the code. And like Will said in his talk, you end up putting 20 breakpoints and not figuring out like which one it is or not finding out where the problem that again. Is kind of cumbersome. So the next step is to use the debugger. In Python 3.7 onwards, you can invoke it with the breakpoint, and before that, with the BDB module. And what it does, it allows you to stop the execution, move around your code, go through it step by step, execute things, inspect things, and you don't need to be bouncing back and forth every time you want to see something new. It comes with a couple of commands, like list, that lets you see where you are, especially handy if you have those 20 breakpoints and you need to know which one caused it. But it also gives you kind of an overview of that part of the code. What happened just before? What's going to happen next? It has commands for moving one step forward, one step backwards. And you get a really granular kind of insights into the execution of the code. Another favorite command of mine is args, which prints all the arguments that your function got at that point. Because if you just look at the code, you might be able to kind of reason that this code does what it should do. And then quite often, the thing is that you might get unexpected arguments to that function. So args just gives you an overview on those. And then it acts as a REPL basically. You can run any Python expressions. You can inspect variables. You can run complete functions. You can change things, see how they work, what goes on. And Debugger is a really, really great tool because it gives you this kind of frozen moment in time to look into what's happening. What's the state? Where did we come from? Where are we going to? And quite often you can find the exact moment and the exact line where the bad thing happens. So it helps you narrow it down. And after that, it's up to you as a software developer to use your skills to fix it. I cannot teach you how to fix the bugs, but I can help you figure out where to find them. A while back I found this really great snippet. If you're using Django with the templates, you can register a custom filter, in this case called BDB, and the only thing it does is that it gets an element, it runs a breakpoint, and then it returns it. So, if you have this registered in your app, and then you do something like this, you use the BDB filter for any kind of data in your templates, it will stop the execution. So you don't always have to go back into the view that is generating this template. But when you work on the front end, you can figure out, okay, I just want to make sure what this does. It's a very limited view because it only gives this function, which is basically one element. But it's much faster and nicer than having to find the right view, adding it there, going back, removing it. So it simplifies your life. The next step from the debugger, I think I counted that this is the third talk that mentions Django debug toolbar. I think it's a good sign. It's a great tool for helping people kind of investigate things on the browser. You saw a couple of examples in Joseph's talk. I just have a screenshot from the project itself. But basically, you get all sorts of information about your request, the SQL queries that got executed, which is really handy. You can see how long things take, and it gives you a lot of information, and it lives in your browser while you use your app in development. You can customize it to kind of match your needs, but kind of on its default configuration, it comes with a really nice ideas and then give them a go. The first one is called Django Run DBG, for Run Debugger. And it's basically you replace the run server with this one. And I've been hearing a lot of good about it, especially when you use an API-driven development. So when you use Django REST framework, for example, it gives you a lot of tools to kind of get into the right spot in the backend on your debugger when you execute those API calls. And the other tool I learned even more, you can find more about it on the Octobot GitHub and on their website. They're the people who made it. And then we've heard a couple of things already today about how to kind of get the best out of your IDE, your editor. I'm the kind of developer who uses editor here, and then I use the terminal to run everything else. So I don't use a lot of IDEs and kind of integrated solutions. But I highly recommend investing time into learning your tools, whatever tools you use. This is a screenshot from PyCharm. I've never used it, but it seems to be very popular. It allows you to do debugger and breakpoints without writing any code. There's a great talk by Luciana about debugging Django in Visual Studio Code, making it easy to kind of debug, interact, do those things within your editor. And very recently, today, I learned about this app called Colo, which really got me excited. For the people maybe watching this later, you should definitely watch Will's talk from a couple of hours ago, when he introduced Colo with really cool visualizations, helping you understand the code. And this is why I love going to conferences, always learning something new. So those were the technical things, and then a couple of non-technical methods. And I think these are really, really important, but often overlooked. Because sometimes the best solution is not to be on the computer. The first one is called brain dump. And the idea with the brain dump is that our brain is rather limited by the things that we can keep in mind. We build mental models, we try to figure things out, but it gets kind of hard to keep everything in your head. So you take a pen and paper and you write down what is the problem in terms of not the code, but kind of what happened, what is the bug, how does it manifest. Then you write down your assumptions about it. I think it happens in this view, or I think it happens in this model, or this auxiliary tooling. You write down all the assumptions to get them out of your head. And you write down what you've actually tried. Not just the things that your brain is telling you that you tried, but try to make sure that you only write the things that you actually tried. Because our brain is quite magnificent, that it skips steps every now and then. It makes assumptions that, of course, I did that. Of course, I've tried turning it off and on again. But that should always be the first step. And the benefit of this brain dump is that we don't have to worry about remembering everything. It's somewhere written down. We can relax. We may take a break, maybe go for a walk, maybe take a nap, sleep over it overnight, go for a coffee with a colleague, and let your subconscious work on the problem. Human mind is really good at that. I got through university math by basically solving the homework while I was sleeping and then waking up and writing the solutions. Because I if you want to learn more about my employer, you can find that on futurist.com. Thanks to the organizers. Thanks to the world getting better that I actually made it here. And I think we're all pretty much ready for the cake. So, thank you.
Thanks so much, Luis. I think we should take at least a couple of questions.
Yes.
Is that slide for me? I know I misunounced the cake break a couple of times. Yes.
It's the best motivator to be on time with your dog when it's just before the lunch or just before the cake.
Do we have a question from the audience? Yes.
You mentioned that you've been mentoring people in this kind of thing for a long, long time. Imagine that you don't know any of those tools, not even print, not the rubber duck, none of the things you covered. Which one has your experience led you to consider the best single one in terms of value for teaching someone?
So, which method? The question is one of the best, maybe the best in your experience, like very long experience to teach new developers to debug?
Yeah, I think there's two sides. I think the most efficient is the duck. Just casting the questions, forcing yourself to phrase your abstract, kind of incomplete idea of the problem into concrete words. But if I'm teaching somebody or mentoring somebody, I would say always start with the print. Because it's the most it's the easiest one to learn. It's something that pretty much every developer does at some point. It's pretty much the first thing we learn. And it is something that doesn't require you to learn complex things and understand a lot about the kind of complexities and hidden things within the code. But it just gives you an understanding of what is happening right now at this right point. And it is especially powerful, not just because we don't know, but worse, we think that we know. So we have assumptions about the state and the data, and it's super important to kind of shut them down as quickly as possible. So for me, it's a rubber duck asking questions. You give an idea to somebody new, just put a lot of print statements everywhere.
And another question. Yes.
Yeah, so Johannes, I've also, for the last year, I've been teaching a Python course, and I also taught my students to use the print, extensively because it's easy. But apparently on TikTok, there's a whole meme on like my teacher told me never to use print or console log, but I still did it. And I wonder where that comes from. Like it's considered dirty, or like it's there's something that's just you're not a real developer if you ever use print. And I had a hard time explaining to my students like why is this considered bad practice?
It's a really good question. So the question is, why is the print statement considered bad practice in debugging?
Yeah, I think it probably comes from this idea that the code that ends up in production needs to be as clean as possible, and kind of leaving any print statements in the production code is kind of considered kind of not great or not kind of pure code. It's not great. So I think it stems from that. And they kind of, we need to understand that there's two different cases. There's putting something in the production code and putting debuggers or print statements inside the code to be taken away. But I think it also comes from, like, if you make a pull request and you've left the console log in JavaScript or you've left the print in Python, somebody will probably tell you that, like, no, take it out, like, remove this. Not maybe the other party understanding why. I'm not in TikTok, so I don't know about the good TikTok memes. I'm happy to learn about that. But yeah, I think it's this kind of also the remember to be kind and understanding to juniors making these kind of things, and not kind of point blank say that this is bad, but explaining them why you don't want certain type of things in production, but it's okay to use them in development.
And nowadays we have Linda's pre-commit. We can actually use the print state and not be afraid that it ends up in production.
Yeah.
I think that will have to be the last question,
Awesome.
as we try to maybe gain 5 minutes of the delay. First of all, before the cake break, big hand for US. Secondly, before the cake break, big hand to Caroline for really, really working hard. Thank you very much. And we'll try to be back again 5 minutes